Now I want to show you how the Robinson map projection lies to us using a really interesting thought experiment. This is a blog by Andy Woodruff. He has mapped the lines of sight looking directly out perpendicular from the world's beaches using a Robinson map projection. These maps are basically answering the question, what would you see on the other side of the ocean if you were standing on the beach looking straight out? The answers are a bit surprising and reveal the disturbing ways that map projections lie to us. These are the beach views from Asia. So he's taken all of the coastline of Asia and created a line that is perpendicular to the coastline and plotted it outwards from the continent. What we see is a lot of these lines are leaving Asia and hitting the north coast of Australia and Oceania, which is expected. There are some hitting the west coast of Africa, some points up here hitting Europe and Greenland, which you might expect. But some of these are a bit surprising, and they're surprising because of the way that the world is represented to us in the Robinson map projection. This exercise of looking at beach views shows how the Robinson map projection is really twisting our sense of reality. For example, there's a lot of lines of sight that leave Southeast Asia and intersect with the east and west coasts of South America. In fact, there are even some views that would curl around the north beaches of Russia and hit the north side of South America. And what's really surprising by this map is this one beach view. There's one place in Asia where you could stand and look out across the ocean, and you would probably be looking at the east coast of Florida in the United States. And I think that that is just remarkable. It's a really good example of how this map and just map projections in general are trying to represent this curved spherical surface on a two-dimensional map. Here's a similar example of a neat map that shows the nearest countries to Madagascar in a straight line. Madagascar here is mapped in an azimuthal projection where the center of the island is the center point of the map. Because the map scale is much larger than a world map, you do not really notice any distortion towards the edges of the map like you would with a world-based azimuthal map. And again, you might be surprised to learn that you can see all the way to Russia, Alaska, California, and Mexico from Madagascar's shores. This might be more obvious if you were looking at an actual globe, but consider how often we see globes in our lives compared with two-dimensional maps. Finally, one last concept that I just want to briefly touch on are what are called antipodes. Antipodes are opposite points on a globe. You can imagine if you drew a straight line through the center of Earth, the points that intersect with the surface of Earth would be considered antipodes. The map shown here has mapped the land masses of Earth from two hemispheres by simply flipping the opposite hemisphere latitudinally and then longitudinally. This map basically answers the question, if I dug a hole straight through the center of Earth, where would I pop out on the other side? As expected, most land masses, including much of Asia, Europe, and North America, you would end up in the Pacific Ocean. There are only a handful of locations where you would end up on another continent, and in no case would you end up on the same continent. For example, New Zealand has several antipodes in Europe. Argentina and Chile have antipodes in China, Mongolia, and Russia. The Philippines maps antipodes almost entirely within Brazil, and Canada even has antipodes in Antarctica. So we've talked a little bit about map projection types and uses. Now I want to start thinking about how map projections shape and reproduce our worldviews, pun intended. As we've seen, projections distort the world, which is not necessarily a bad thing. It is important to recognize how a particular map projection distorts different properties of maps so that we can develop maps that are useful for specific tasks. For example, equal area projections are useful for comparing areas, and azimuthal projections are useful for finding direction and distance from a single point. But map projections can also be used to reinforce certain power structures, like colonialism, international influence, and even racism. Consider as an example the symbol of the United Nations. This is an azimuthal projection centered on the North Pole and oriented to the prime meridian. What is near the center of this map? Russia, the United States, China, France, the United Kingdom, all of the permanent members of the UN Security Council. Now, what is at the periphery or the edge of the map? The continents of Africa, South America, and Australia. What does this orientation of this map imply about the northern versus southern hemispheres? What about the eastern and western hemispheres? This projection reinforces ideas of colonialism with the positioning and distortion of Africa and South America. It also appears to put the eastern and western hemispheres at odds with each other, divided by the prime meridian. It is no coincidence that this projection was adopted by the United Nations to reinforce the power and the importance of the permanent members of the Security Council. Recall that distortion increases as you move away from the center of the map, so countries at the periphery look nothing like they naturally do. The choice of how to center this map is also interesting. Again, with an azimuthal map projection, they could have chosen any other point in the world and centered it on that point. But because this is the United Nations, they decided to center it on the North Pole, which is a politically neutral point. Also, they have a lot of choice about how to orient the Earth on this map. So just as they could have chosen any other point on the planet to be the center point of this map, they could have also spun this Earth around instead of centering it on the prime meridian that runs through Europe.
Hi, I'm sorry.
Hello.
Sorry to be late.
Not a problem.
I'm CJ Craig.
Of course you are. I'm Dr. John Fallow. This is Dr. Cynthia Sales and Professor Donald Huke.
Huke?
Huke.
Okay, and you are the Organization of Cartographers for Social Equality.
Well, we're from the OCSE. We have many members.
How many?
4,300 dues-paying members.
What are the dues?
$20 a year for the newsletter.
Let's start.
Wait, I want to see this.
This is Josh Lyman.
Indeed you are.
Josh, this is Dr. Fallow, and
Hi.
his merry men.
Yes.
Should we begin?
Yes. Plain and simple, we'd like President Bartlett to aggressively support legislation that would make it mandatory for every public school in America to teach geography using the Peters projection map instead of the traditional Mercator.
Give me $200 and it's done.
Really?
No. Why are we changing maps?
Because, CJ, the Mercator projection has fostered European imperialist attitudes for centuries and created an ethnic bias against the Third World.
Really?
The German cartographer, Mercator, originally designed this map in 1569 as a navigational tool for European sailors.
The map enlarges areas at the poles to create straight lines of constant bearing or geographic direction.
So it makes it easier to cross an ocean.
But
Yes.
it distorts the relative size of nations and continents.
Are you saying the map is wrong?
Oh dear, yes. Look at Greenland.
Okay.
Now look at Africa.
Okay.
The two land masses appear to be roughly the same size.
Yes.
Would it blow your mind if I told you that Africa is in reality 14 times larger?
Yes?
Here we have Europe, drawn considerably larger than South America. When it's 6.9 million square miles, South America is almost double the size of Europe's 3.8 million.
Alaska appears 3 times as large as Mexico, when Mexico is larger by 0.1 million square miles.
Germany appears in the middle of the map when it's in the northernmost quarter of the Earth.
Wait. Relative size is one thing, but you're telling me that Germany isn't where we think it is?
Nothing's where you think it is.
Where is it?
I'm glad you asked. The Peters projection.
It has fidelity of axis.
Fidelity of position.
East-west lines are parallel and intersect north-south axes at right angles.
What the hell is that?
It's where you've been living this whole time. Should we continue?
Uh-huh.